At the bottom of page 1 of the notes for 7.3, the instructions say use the method of your choice to factor each trinomial or state that the trinomial is prime. So the book method has a guess and test. We're talking about converting the 3 terms to 4. There's other methods out there. Some people like to use the box method. And then you can check each factorization using FOIL multiplication. So you can refoil it to check to see if you got back to the original, and that's how you know if you've got the right factors. So let's look, we'll continue doing our method using these steps for a strategic split. And we're going to multiply a times c, a and c coming from the standard form of the trinomial, ax squared plus bx plus c. And in this case, our a value is equal to 3, our b value is equal to 5, and we do want to note the sign. We want to keep the sign of the b value with it. We just want to take the plain old c value. Our c value is 2, but we are going to note that it's positive because that's going to tell us to add our pair in just a moment. So we're going to multiply a times c. So when we do that, we're going to take our a value times our c value. In this case, it's 3 times 2, which is 6. And then we're going to strategically split it. I'm sorry, we're going to list the factor pairs looking for the pair that will let us do the strategic split. So we're going to list factor pairs of AC until we can find and use a pair that adds to equal B if our C is greater than or equal to 0. In other words, if we have a positive C value, which we do in this particular case. Or we're going to find and use a pair that subtracts to equal our B value. B value in this case is positive 5. If our C value is negative, it's less than 0. So we have 2 situations. Either the C value is positive or it's negative. So we've multiplied our A times C. The difference between this section and the previous section, 7.2, all the A values were 1 in 7.2, which really lends itself to that nice guess and test because you're just trying to split up factors of that C value. Now here we're looking at a combination of the A and C. You can still do the guess and test, and some people like that. It's a little bit challenging for some, but some people like that kind of challenge and like the puzzle sort of feel to it. But it is something that could take more time as the numbers get bigger. So the method that I show takes a little bit of extra time on the easier problems, but it's guaranteed to find you the answer every time, and you won't feel like you're kind of digging around and wondering if you just have missed a combination. This eliminates all the possibilities and finds you the combination that works. So back to what we're doing here, we did A times C, 3 times 2 is 6, so we're going to see how many different ways you could split that, and we're looking for a pair that when it adds together, it'll give you the 5. So we've got 2 options, 1 times 6 and 2 times 3. Both of those give you 6 when they're multiplied. But we're looking for something that you add, and the combination here is going to be 2 plus 3 equals 5. Okay? So when you add them, they're both positive. So that means our split is going to be 2x plus 3x is equal to our 5x. So that's why we did this. We're going to take our 5x and split it into 2 terms, 2x and 3x. And then we're going to keep our original pieces as well. We've got our 3x squared that we started with, and we've got our plus 2 that we started with. So here's our converted to 4 terms. 3x squared plus 5x plus 2 is the original. 3x squared plus 2x plus 3x plus 2 is the new converted to 4. Now, some of you might think, well, what's the difference? Can I split this any way? Can I do this 1x and 4x? Could I do this 0x and 5x? The reason why you can't just grab 2 numbers is because we need them to add to give us 5, but multiply to give us 6. Because remember, these are the pieces that then make the foiling, that first, outside, outside, inside, inside, last, last. So they still have to multiply to be able to give us the back to the original. The other question that people have usually is, does it matter which order I put these in? And no, it doesn't. Order does not matter. but the signs do. So when you have a situation where you're subtracting, whatever you're subtracting has to keep that negative sign with it when you put them back. So you could switch these and put the 3x here and the 2x on the right side, and it will work. In fact, some of you might want to try that to prove that to yourself. Make this 3x squared plus 3x plus 2x plus 2, and then finish out the problem with factoring by grouping. Your answer should be the same. And let's do that now. We are at the, we did the split B term, we kept the signs, but order doesn't matter here. So you could switch it and do the same thing I'm about to do. It'll look different for a couple steps, but our final answers should match. So we've converted to 4, which means now we get to factor by grouping. So this is now converted to 4 terms. So now we factor by grouping. And this is from what we practiced in the second part of 7.1. So we look at the first 2 terms and see what they have in common. In this case, the 3x squared and the 2x have an x in common, and we factor that out. We get 3x plus 2. In other words, we're undistributing. Imagine dividing both pieces by the x, what would be left over? So the 3x plus 2. And factoring by grouping, once you start doing these enough, you start to realize you can expect a match here. We can expect 3x plus 2 to show up again, and sometimes that's helpful to kind of give us a clue of what we need to take out in terms of a GCF of the next 2. So we looked at the GCF of the first 2, GCF of the second set of 2 terms, and you look at 3x and 2, and there really is nothing in common, but we know that we want that to match, and it already looks like that. So we're really not going to divide anything out. We're just going to divide by 1. We're going to take a GCF of 1 here. There has to be some sort of GCF. So if it looks exactly like what you want anyway, just use 1. And that, of course, leaves behind the 3x plus 2. If we were to redistribute the 1, we'd be back to just the 3x plus 2. So now we have exactly matching, which was what were we expecting. So we can expect the match right here. And now imagine zooming out here, kind of big picture, and what does this whole thing have in common? As you look at the left side, the plus here at the right side, they both have a 3x plus 2 in common. So now that comes out 3x plus 2, and that leaves behind the x plus the 1. So what's left behind when you pull out that quote-unquote big GCF is x plus 1. And our final factored version is 3x plus 2 times x plus 1. If you had switched around the 3x and the 2x, the first 2 terms would have a 3x in common, and that would leave behind an x plus 1. So you'd have the next 2 steps would look a little different, but your final factored form, it might have the x plus 1 in front of the 3x plus 2, but multiplication is commutative. So you can switch those back and forth and it will not matter. It is the same factors. Let's look at number 8 on page 435. And the question here is, what's different about this one? Well, not too much actually. The y squared and the y are different, but it's not going to change anything in terms of how we do this. We just treat these as if they were the x's. So it'll be y's that's happening instead of x's. Won't be a problem as we do this here. We've got a minus subtraction here, so we just want to take note of that. That's a little different too. When we pull out the b value, we keep that sign, so we're looking for a negative 17 as we go along here. So let's go ahead and recall that we're looking at ax squared plus bx plus c. So our a value is 5, our b value is negative 17, our c value is 6, and we're going to note that it's positive. It's a positive 6, which means we're going to be adding our factor pairs to find that combination that will give us the negative 17. So we start by taking our a value times our c value, in this case 5 times 6, which is 30. And some of you may be able to do this part in your head, which is great. That'll speed things up. And when you do that, either on paper or in your head, once you find the pair that works, in this case we're going to find a pair that subtracts to give you 17, then this will, I'm sorry, I'm a little distracted here. There's something on my pen. Okay. Once you find the pair that subtracts to give you 17, this will be, you can stop right there. So let's go about this here. 1 times 30, 2 times 15, 3 times 10, 5 times 6. So there's your pairs. And as we look at this, we've got, we're going to be adding, I'm sorry, I kept saying subtract. That's what was distracting me. Let's add, we're going to be adding these two numbers together. Well, when you look at this, is there a way to add to get negative 17? Well, yes, if you consider that to get a positive 30 here, we could have negatives. We could have a negative 1, negative 30, negative 2, negative 15, negative 3, negative 10, negative 5, negative 6. And then when you would add those together, what would happen? So to get a negative 17, we'd want to add this second pair right here, a negative 2 plus a negative 15. So let me go over that again and be real clear about that. We have a 5 times 6. We're trying to get a positive 30 out of our multipliers here. And so we're listing our pairs that multiply to give us positive 30. And because it's positive, we know we're going to be adding. Because of this sign in front, we're going to be adding them together to try to get negative 17. But when it was just plain old 1 and 30, 2 and 15, 3 and 10, 5 and 6, when you add those together, the only thing you get is positive results. So to be able to get negative results, but also add them together, as well as multiply them to get a positive 30, you make them both negative. So when you're trying to add them together to get a negative value, realize that both factors are negative. So this takes a little bit of getting used to, and that's what's really different here, is the fact that there's a negative, which means we're going to be adding two negatives together, okay? Because a negative times a negative equals a positive. And I totally understand if this starts to be a little bit confusing. If it was going along great for you, but this part's a little confusing, as you do more and more examples, it will start to fall into place for you. Okay. And again, you can always fall back on the guess and test method to kind of check yourself with that. And the guess and test method, just by the way, is just simply, hey, I'll just know it's going to go into the FOIL look. First and outside, outside, inside, inside, last, a binomial and a binomial. And so then you just start trying different splits of the 5y and different splits of the 6 and different combinations of the signs in between until all your pieces work out for the foiling. And some people can get really good at that, and others it may take a while. So just watch for that and figure out what is the method that works best for you. So in this case, we have said that the strategic split that we need is negative 2 plus a negative 15. So it's going to become negative 2y and a negative 15y, or you can think of it as plus a negative 15, however you want to do that. And it really doesn't matter which order. In fact, I'm going to go ahead and reverse the order just to show that it really doesn't matter. So instead of the negative 2y plus negative 15, I'm going to put that negative 15 first. So I'm splitting this into negative 15y plus a negative 2y. And then I'm bringing down the 5y squared, and I'm bringing down the plus 6. Sorry, my other problem kind of got in the way here. So now I've converted to 4 terms. I've done my strategic split. I've converted to 4 terms, and now I get to factor by grouping. So I look at what the first two have in common. They're going to have a 5 in common and a y. And because the first one is positive, I go ahead and just pull out a positive 5y. Even though the second one's negative, I don't worry about that right now. What that leaves behind is going to be a y minus 3. If I were to redistribute the 5y times y is 5y squared, 5y times negative 3 is negative 15y. Next, I look at these second two terms, negative 2y plus 6, and I note that the first one is negative, The first one is negative. It's a little reminder that I should pull a negative GCF out. If I forget, what'll happen is I'll get really, really close to an exact match, but not quite. The signs will be off. So that's my reminder. Oh yeah, I should have pulled a negative. So what do negative 2y and 6 have in common? They have a negative 2 in common, leaving behind a y minus 3. Negative 2 times y is negative 2y. Negative 2 times negative 3 is the positive 6. And again, it shouldn't surprise us. In fact, that's what we were expecting, is for there to be a match here. And then we pull that out. As our big GCF. What's the GCF of the whole thing? So we pull that out in front, and then what's left behind is our 5y minus 2. And there's your two factors. Y minus 3, 5y minus 2. You could FOIL that out to get back to your original as a way to check. So take a moment, kind of talk these through. Very, very similar steps and strategies as to what we did in 7.2. Oh, and I'm realizing now, I got so caught up in working on the strategic split, I forgot to do our boringly good strategy at the beginning, and this is what we can easily fall into because these are primed and ready for us to practice the split. A lot of them don't have GCFs to start with. We should always try to remember, is there a GCF at the beginning? No. How many terms are there? 3. Great. Our plan is to convert to 4. And for this one, just for good measure, was there a GCF right at the beginning? No, there was nothing that all 3 had in common. How many terms? There's 3. Great. Our plan is to convert to 4. Okay. It's not the best to forget. It's best to do it at the beginning, but at least I remembered. It would have shown up later had there been a GCF and I missed it. There would have been one kind of hidden in one of these factors. We would have had to pull it out. It wouldn't have been factored completely until we pulled that GCF out. Take a moment to talk these things through. Know any questions that you have, bring them to class or to your help. We have plenty of time each class day. Please ask those questions. No questions too small, no questions too big. Let's just work on these together till we get really, really good at them. And now it's time to pause the video while you can try number 14 on your own. And after you do so, you will find that the answer to this one should be, in factored form, should be 3x minus 7 and x minus 1. And again, it doesn't matter. You could have the x minus 1 first and the 3x minus 7 second. It doesn't matter which order, as long as inside matches.